College Algebra, topic 3.4. We're finding the domain of these two functions. This is an even root. The rule for even roots is to take the function, not the function, but the expression out of the radicand and set it greater than or equal to 0, and then solve for x. When we solve for x for these inequalities, we look at the expression that is greater than 0 as looking for positive pieces. So I'm going to turn this into x squared minus 9 equal to 0, and then solve. X plus 3, x minus 3. We get x plus 3 equals 0, x minus 3 equals 0, and x solves to negative 3, and x solves to positive 3. I will put both these answers on number line. Again, this is the old stuff right here, the old way of solving. Then on the number line, I have a negative 3 and a positive 3. Since we have equal signs, these will be filled in, and then I'll need to test each one of these areas. So I'll say x equals negative 10 for this area, x equals 0 for that area, and x equals positive 10 for that area. If x is negative 10, we get negative 10 plus 3, which is a negative answer. Negative 10 and negative 3 is also a negative answer. A negative answer times a negative answer is positive. So this area is positive. Now for 0. 0 plus 3 is positive. 0 minus 3 is negative. A positive answer times a negative answer is negative. Next, x is 10. 10 plus 3 is a positive answer. 10 take away 3 is also a positive answer. So a positive answer times a positive answer is positive. And since we're looking for positives right here, it'll be this area and this area, which is negative infinity to negative 3 with a bracket, union, a bracket here, and 3 to positive infinity. And this is my domain. Okay, number 6. Number 6, since we have a root and it's in the denominator, when we remove the root, 25 minus x squared, this will be strictly greater than 0. No equal sign. No equal sign because it's in the denominator. Alright, so greater than 0 means we're looking for positive pieces. And so we're going to turn this into 25 minus x squared does not equal 0. And then we're going to solve this by factoring. So I get 5 times 5 plus x minus x, and then 5 plus x does not equal 0, and then 5 minus x does not equal 0. Subtract 5 from both sides here when I solve for x, and I get x does not equal negative 5. Here I'll add x to both sides, and I'll get x does not equal 5. I'll put these two on the number line. Negative 5 and 5. And you notice that these are not equal to, so these will be open circles, both. Now I need to test these areas. I will test this area here with negative 10, 0, and positive 10. Negative 10, 5 and a negative 10 is negative. 5 in the opposite of x, which is opposite of 10, which is positive 10, which would be positive. A negative and a positive means that this area right here is negative. Now with a 0, x is 0, 5 plus a 0 is positive. 5 minus 0 is positive, so that would be a positive and a positive. So this area is positive. Lastly, this area right here, x is 10. 5 plus 10 is positive, but 5 minus 10 is negative. So a positive and a negative gives us a negative area. And since we're looking for the positive areas right here, this area will be our answer. So it'll be between negative 5 and 5. And this is our solution, or our domain.